Today we will be discussing the contrast approach to extracting a rat's brain from an MRI. The program that uses the contrast approach is all within a for loop. The for loop runs across each slice of the MRI, starting at slice 50 until the end. Slice 50 is where the brain starts to become noticeable. First, the program calculates the length and the width of each slice. Then it calculates the length times 75%. This is so that the bottom 25% of the image can be cut, because below that the brain never appears throughout the entire MRI scan. In the next part, the bottom 25% is actually deleted, and after that, all the remaining parts of the slice are all summed up together, and the average value of the remaining parts are calculated. This is the average brightness of the image. After that, a simple blur through a Gaussian blur is applied, and then after that, a binarization is applied. This is the binarization function. The binarization function takes the grayscale that's been cropped and then applies a threshold to determine where to cut off the brightness. So anything that has been calculated as below 0.75 times the average brightness will be deleted and turned into black, and then anything above that will be turned into white, and that will create a logical image. So the logical image is stored, and then it's applied with labels with black-white label. So now that the logical image is labeled, all of the objects in the logical image are labeled, and the centroid is calculated for each one. So this is the centroid function through region props. So all of the centroids are calculated, and after that, all of their distances from the center of the image are calculated. The center of the image is a point where it's not actually the center of the image. It is a point where it is predicted that the brain will most likely be. So that is actually determined up here before the program as a constant. This constant was calculated before this program was created. From the middle slice of the MRI, the centroid was found at the middle slice, and from that point, that is where the brain will most likely be in all of the other slices. So that the distance of each white object is calculated from that predicted point in this section right here. So here's the distances. They are all stored, and then the object that is the closest to that predicted point is most likely to be the brain. So you have several white blobs on the screen, and they are all labeled, and whichever one is closest to where the brain ought to be, then that one is most likely going to be the brain. So using that, all of the other slices are eliminated, and that will, for the most part, only leave the brain. So after that, an infill is used to fill in any remaining holes in the brain, in the logical image of the brain, and then finally the logical image of the brain is applied and multiplied times the original grayscale in this function right here. It's a simple pixel by pixel multiplication. Thank you very much for watching.